Welcome to the Introduction to Process Dynamics and Control session. This session will be benefits to the chemical engineering students, also whoever beginning with the Introduction to Process Dynamics and Control. Myself, Dr. K. Sophia, working as an assistant professor in the Department of Chemical Engineering, SRM Institute of Science and Technology. In today's presentation, these are the content I am going to present. The importance of process dynamics and control. What are the basic concept of control system? What is meant by closed loop diagram? What are all the terms and terminology used in control system? Some of the examples of process control system. What is the difference between open and closed loop system? So let's begin with the importance of process dynamics and control. Actually, why we need to study the process control? Actually, the chemical engineers are known as a process engineers. We need to work in different environmental conditions. So wherever we are working, we no need to go directly to the environmental conditions. We can sit in front of the computer, then you can control the entire process. So the entire operation will be very safe. So that's why we are going for the process dynamics and control. So if you are applying a process dynamics and control, the pollutants that led into the environment also very less. So environmental constraints also will be there. So because of this process dynamics and control, efficient use of material and energy will be there. So because of this efficient use of material and energy, there will be increase in profit of the process will be there. So because of increase in profit, also the entire process we can handle in a economic way. So there will be product specification we can achieve. So these are the some of the importance of process dynamics and control. So why we need process dynamics and control? What is the need of process dynamics and control? So in the actual process, there will be a number of disturbance to the process generally. So sudden changes in the flow rate or sudden changes in the temperature. So several disturbance will be occur during the process. Okay. So all the disturbance will be suppressed if you are going for the process control system. Then there will be stable operation will be there. If you are implementing the control system, the operation will be stable. Then optimization also we can achieve if you are applying a process control and system. So by this, what is the overall aim or objective of this process control system? In the process control system, we are going to maintain a variable as constant. So what are the variable like temperature, pressure, level, flow? So we are going to maintain as a constant even though the time varies. So that is the ultimate aim of the process control system. So if the process is already in steady state process, there is no need of control system. If it is in dynamic, if it is in unsteady state, then we need to control the variable as constant. There we need a process control system. Okay, now we'll begin with the what are the basics concepts of control system. So I'll explain through a liquid level tank. So I think everyone we are aware of the liquid level tank. So take a tank process. In that tank process, there will be a continuous inlet and continuous outlet will be there. So even though if it is a continuous inlet and outlet, so our aim here is to maintain the level as constant. That is our ultimate aim here. So the level in the tank we wanted to maintain as constant. So generally in what we'll do, so every time we will observe the height or level, then we'll based on the level we'll adjust the valve. So the either we can adjust the outlet flow rate valve or inlet flow rate valve. So this operation generally we call it as a manual mode. So in a manual mode, a person has to stand in front of the tank. Then he or she has to observe the level. So based on the level, we have to adjust the valve flow rate so that the required height will be maintained. So this is the manual mode. The same liquid level tank, there will be a continuous inlet and continuous outlet will be there. How we are maintaining by the control mode? So the level in the tank will be measured by using a measuring instrument. Usually we call it as a thermocouple or any temperature sensing device. So that measuring instrument will produce a measured variable that will go to the comparator. So in the comparator already the set point will be given. So what is the job of comparator now? The comparator will compare set point and measured variable, generate error. So that error will go to the controller. So what is the role of controller here? Controller takes an error as an input. Proportional to the error, it releases an output signal. So this signal used to control the valve flow rate so that the required level will be measured. So you can see the difference between manual mode and control mode. Instead of a person, a controller will control the flow rate here. So this is how the control system is working. I think the animated liquid level tank is given here. Here, instead of level measuring device, they are using sometimes a float. So the float will measure the height of presence height. So it will be given to the comparator, then to the controller. The controller will control the valve flow rate. So this is how the control system will be working. So now what is meant by closed loop diagram? So the given control mode we can give in terms of a closed loop diagram. So how? Let's see now. Take a process. This process may be of any unit operation or any other process, any other unsteady state process. In this process only, we wanted to maintain a variable as constant. So what we are doing, we are taking an instrument based on the which variable we are going to measure. So that instrument will measure the variable from the process. That value we call it as a measured variable. That measured variable will be given to the comparator. So in the comparator, already the set point is given. So now the set point and measured variable is compared. Then it generates an error. So now what the error will go to the controller. So now the controller will give the signal that is directly proportional to the error. Then the signal will go to the final control element. That final control element will give you a manipulated variable. Then the process variable will be adjusted. Then finally we are getting a controlled variable. So if you are connecting all the elements together to explain the control system, it's known as the closed loop block diagram. So in the closed loop block diagram, whether we are indicating by positive or negative sign, the positive sign indicates the positive feedback system. The negative sign indicates a negative feedback system. Now, what are the terms and terminology used in control system we are going to discuss. First thing is the set point. The set point is nothing but the variable which we wanted to maintain as a constant, or this is the objective variable like temperature, pressure, etc. Then measured variable. Usually the measured variable will be obtained from the instrument, that is by using instrument or sensor. It will tell the current value of the process. Comparator. So what is the role of comparator? It just compare the two value. One is set point and another one is a measured variable. So based on the set point and measured variable, it's generate an error. Now what is the error? The error is nothing but the difference between the set point and the measured variable. It may be a negative or positive. Controller. So what is the controller? The controller we can compare with our human brain. What is the job of the controller? The controller will take error as an input. Proportional to the error, it produces an output signal. Now what is output signal? The output signal will be generally in the form of electronic or pneumatic. If it is electronic means current will be applied. If it is pneumatic means pressure will be applied. So final control element. So what is the role of final control element? It's used to produce a manipulated variable to the process. Example, you can take a valve or switch. So what is manipulated variable? So manipulated variable is the adjusted value to bring the variable back to the set point. That variable we call it as a manipulated variable. What is controlled variable? So the controlled variable is nothing but the final value that will be maintained in the process. So your ultimate aim is to maintain the controlled variable that should be a constant one. What is negative feedback system? The negative feedback system, the measured value will be generally detected from the set point. That is negative feedback system. What is positive feedback system? Generally the measured values added to the set point will have a positive feedback system. So most of the systems are negative feedback system. some of the examples of process control system, I think we can take a natural process control system as an example so that we can understand easily. So assume we are riding a bike or cycle in the road. In the opposite, we are seeing a speed breaker. So suddenly our eye will measure, I will guess, oh, there is the speed breaker, it is there. Okay. So that information will be given to our human brain. So our human brain will give a signal to our hand to apply a brake. So this is the actual phenomena. It's happening in every day. So that is, it is an example of natural control system. Here, the riding a cycle or bike is a example of process. Seeing a speed breaker in opposite, it's nothing but a disturbance. So the measuring element is a human eye. Human eye will measure the speed brake and it will give a signal to the human brain. So here our human brain is the best controller. Actually, the best natural controller is our human brain. So now the final control element is our hand to apply a brake. So this is how the control system also working. Now we can see one more example how we are controlling the reactor temperature. Assume there is a continuous stirrer tank reactor. In that reactor, we wanted to maintain our process temperature as constant. So why? Because some of the process, some of the reaction will be carried at constant temperature only. So our aim here is to maintain the reactor temperature as constant. So now first what we are doing, we are taking one measuring instrument or sensor. We'll measure the current temperature. That temperature we are giving to the comparator. In the comparator, already we have given a set point. That is the temperature that we want to maintain. That temperature will be given to the comparator. Now what a comparator will do? The comparator will compare both value. One is set point, another one is measured variable. Then it generate error. That error will go to the controller. Now what the controller will do, it will take error as an input. Proportional to the error, it release an output signal. So that output signal, it's used to control the coolant flow rate in the reactor. So this valve is nothing but final control element. So the signal from the controller will act on the valve so that the flow rate will be adjusted. So now whenever there is an increase in or decrease in temperature of the reactor, the control system will adjust the coolant flow rate in the jacketed vessel. So until the constant temperature is maintained. So this is how the process control system is working. So now let us see the what is the difference between open and closed loop system. In open loop system, the input will be given to the process, then the output will appear. The output will not connected anywhere to the input. That system we call it as a open loop system. So in the closed loop system, each and every element we call it as a open loop system. In the closed loop system, the output from the process, it will be given as an input. Generally, the feedback will be collected from the process. That feedback will be given as a input. That system we call it as a closed loop system. Let us see with the example. All we know the traffic control system, how it is working. So every 60 seconds, the traffic control system is working. The people move from here to there. Once in the open loop system, the density of the people or the crowd of the people will not be taken into the account. So for every 30 seconds, the system will be automatically open and close. But in case of closed loop system, the same traffic signal, the density of the people or crowd of the people will be taken into the account. Based on the crowd or density of the people, the controls, the traffic signal will work. So that is nothing but feedback system. Generally, what we are studying is here is feedback system. We'll get a feedback from the process. Based on the feedback, the control system will be activated. So this is a simple feedback system. Thanks for watching this section. Thank you.